Okay, so welcome to the lectures of signal processing techniques and its applications. So today we talk about signals and its types. So we talk about what is signals, because before we start signal processing, we have to know what is signal and what is signal processing. So today we talk about signals. What is a signal? Many people are asking, what is a signal? What is signal? Signal, anything, you can go to the traffic signal. There is many kinds of that. You waves your hand, giving a signal to your friends. So what is signals? If I ask you define signals. So if I want to define the signal, so signal generally convey information about the state or behavior of a physical phenomena. So any physical phenomena where its states or behavior of the phenomena is represented by a signal. So anything, suppose you are calling your friend by waving the hand, it is a signal. So you are conveying information to your friend that you are calling. So that is a signal. Now, if I go for the mathematical definition, okay, that is I know, okay. So any physical state or behavior of a physical phenomena is called signal. Now, when I define in a mathematics, so in that case I can say, so a signal is a function that convey information about a phenomena. So when I say a signal, so it is nothing but a function. So in mathematics I can consider a signal has some information. So how do I represent it? It can be represented by vectors. So as you know, the vector has an amplitude as a direction. So I can say a signal is nothing but an vectors, fx is a vectors. So it may be fy, it may be fz. So a signal is represented by a functions which has an amplitude or which has an, you can say that value, and it has a direction. So anything about a phenomena or state of a physical phenomena is signal. Then many people say, is noise is a signal? Yes, noise is also a signal. So in context, so if you see in a context, if the signal is unwanted, then I call that signal is a noise. Suppose I am speaking to you. So while I am speaking, the signal which is coming out from mouth is a signal for you. But suppose somebody is playing the box while I am speaking to you, and that playing a song or that playing a music, that music is also a signal, but it is noise to you because it is unwanted in that context. So noise also a signal. So signal is nothing but a physical phenomenon, behavior or state of a physical phenomena. And noise is also a signal, but it is unwanted in a context. I can give you another example. A lot of you have already studied that information and data. If I ask you what is information and what is data, all of you have already gone through that information, data. Oh, this so many data, the TV data is required, internet data. And when you say information, then what is the difference between the information and data? Data is an evident of a phenomena, and information is meaningful evident is an information. So when I say noise, noise is also a signal, but when it is unwanted in a context, I call it is noise. Then what is signal processing? It may be analog, it may be digital. Signal can be processed in analog domain and digital domain. So when I process in digital domain, Then I call digital signal processing. When I process in analog domain, suppose you design an analog amplifier. Given analog signal, the amplifier will amplify the signal. So this is also an processing. This is analog signal processing. So if I define signal processing only, then I can say the process of operation in which the characteristics of a signal undergo a change known as a signal processing. Suppose I said I have an analog signal, I want to amplify it 3 dB. So I design an analog amplifier, I apply the signal in the input and output I get that amplified signal, the signal is amplified by 3 dB. So I am changing the amplitude of the signal. So I am changing the characteristics of the signal. So that's why this is called signal processing. Similarly, I said digital signal. So digital signal I want to amplify. So digital signal is nothing but a number. The amplification means I want to multiply by something. That is digital signal processing. So people may say, what is the advantage of digital signal? Why we go for digital signal processing? If I do for analog signal processing, then why should I go for the digital signal processing? What is the requirement of a digital signal processing? So digital signal processing, what is the benefit or what is the requirement? If you want to buy a music system, then people will sell, the sales girls will say signal processing is inside, digital signal processing is inside the system. What do you mean by digital signal? What advantage is there? Just I give an example. If you have a radio in your home or old tape recorder in your home, then if you see after 5 to 10 years or 5 years, that radio quality of the sound is decreases. Or you can say, while you are tuning your radio, tuning is not that perfect. So what is the problem? Problem is the tolerance of the component. So in your radio also use component. That means when I design an analog amplifier, let us say analog amplifier, I use resistance, I use capacitance, and every component has its tolerance and also change along the timeline, because components, a capacitor can be developed a leakage. So the value of the capacitance will be changed. So the component tolerance is an important issue in case of analog signal processing. Now when I go for the digitization, then amplification, what is the meaning of amplification of it? Suppose I have a number called 1000, I have a number 1000, I want to amplify by 2 times. That means I want to multiply by 2. So in digital domain, the amplification is nothing but an algorithm, where I am amplifying the number by a number. So it is an algorithm. So algorithm will run on a processor. So algorithm does not have a component tolerance. So today if I design an analog filter, maybe after 2 years the due to the component tolerance or component leakage, the 1 kilohertz filter may becomes changed. Now if I design a digital filter, it is an algorithm. So algorithm will never change. And designing a complex processing in analog domain is a very difficult task, but in digital domain it is a very easy task. But people may say, then why not all that processing, signal processing in digital domain? Why still that analog signal processing? You know that RF amplifier cannot be designed in digital domain. Why? So the problem is, any real world signal is an analog signal. If I want to, suppose I am speaking, it is an acoustic signal, and when I using a microphone, when I convert it to an electrical signal, it is an analog signal. I am coming. What is analog signal? I am coming. So it is a continuous time and continuous valued signal. That's why it is called analog signal. So now if I want to process it in digital domain, then first step is that I have to convert this analog signal to digital signal. So I cannot convert that process of conversion has a complexity. I cannot convert a high frequency analog signal to the digital domain. I will explain it when I talk to that analog to digital conversion. So there is a certain requirement for analog to digital conversion, which requirements are so specific that if that signal is very high frequency, the digital conversion is very troublesome. So we cannot, sometimes it is not possible also. So if it is not possible, then I cannot process it in digital domain. So both analog and digital signal processing exist. Digital signal processing advantage is that it is nothing but an algorithm, that it will not change. It will not change with temperature, it is not change with tolerance of the component, and it is also not so much expensive, because if I design an amplifier, the specification is fixed. But if I design an amplifier and if I want to change the gain in case of a digital, it is nothing but to change the multiplication number. Suppose I design an analog filter and for 1 kilohertz I want to make that it is 2 kilohertz, just I change the algorithm, nothing will change. But in case of an analog system, I have to change the entire system. So those are the advantages and disadvantages of an analog and digital processing. So since digital processing has so many advantages, that's why people are talk about the digital signal processing. Again, it has a limitation. Limitation is that high frequency signal we generally cannot convert in digital domain. That's why digital signal processing are restricted to a certain frequency range, and why I will explain when we talk about analog to digital conversion. Okay. So now I come to the signal. So you said signal. Signal is a function. So a signal is a function of something which is varying. Okay. So let us say a signal XAT is a cos omega t. I can say the signal which is a time varying signal along the timeline, the value of the cos will be changed. You know the cos curve will look like this along the timeline. Okay. And the value of XAT is real. So I can say this is a real signal. And this omega is called analog frequency, or I said radian per second, analog frequency. You know the what is frequency. So radian per second, this is the analog frequency. That is why omega t plus theta. Theta is called phase and A is called amplitude. So this signal has a particular one frequency. I can say that I have a signal which is a combination of two frequency, one is omega, another one is omega 1, will look like this. So I can say there is a global variation, you can say there is a variation look like this. So and there is a some variation like this. So I can say that is a composite signal. Okay. So signal basically if the value is real, I said real value signal. Similarly, let us say the speech signal. When I am speaking, if you record it using your microphone and if you display it, it will look like this. There will be a different speech event at different position. Okay. And the values are real, not complex. So then it is called real signal. Now if you observe this curve, this three curve, if you see along the timeline, suppose I take the signal from here and I take the signal from here, here also it is cos omega t and here also it is cos omega t. But if I take the signal from here and if I take the signal from here and here, the signals are different. This is a sibilant vibration kind of signal, there may be a periodic signal, there may be again sibilant signal. So, along the timeline, if the signal does not change its property, it is called stationary signal or time invariant signal. Along the timeline, signal does not change its property. So, I said that along the timeline it will always remain cos omega t plus theta, it will always remain cos omega t, oscillation will be omega only. But in case of speech signal, beginning may be a sibilant, there may be a vowel, there may be a consonant, retroflex or trill consonant, there may be again vowel, there may be a voiced consonant, vowels. So, signals are changing its property along the timeline. So, then it is called time variant signal or non-stationary signal. Stationary signal, non-stationary signal. Along the timeline, if the properties of the signal change, we call non-stationary signal. Change, if it is not change, we call stationary signal. Okay? Now, I come to the complex signal. So, if the signal value is the real, I said real signal. Now, I come to the complex signal. Let us say I have a, all of you know the complex number alpha plus jb is nothing but a complex number. So, it is in a complex plane, this is the real axis, this is the imaginary axis. So, this coordinate is alpha and beta. Okay? So, this is a complex signal alpha plus beta to the power n un is a signal. Let us say is a complex signal. What is un? I come later on. Okay? So, what is there? Now, alpha plus beta, the value of the signal is not real, it is complex. So, I know any complex number can be represented its magnitude and direction. This is a very good, very much important issue. Many of the time when we go for the signal processing, whether digital or analog, we always represent a signal with an amplitude and a phase. Phase is represented by e to the power j theta and r is called amplitude. So, alpha plus jb can be represented by r, which is the amplitude. So, this is alpha, this is beta. So, I can say r is equal to root over of alpha square plus beta square, because this angle is 90 degree. Okay? So, that is the distance, how far it is from the origin. So, I can say as you know, any Cartesian coordinate can be converted to the polar coordinate. So, here alpha plus beta is a Cartesian coordinate in I axis, I and real axis and imaginary axis coordinate system. So, I can represent it by a polar coordinate, which is r and theta, angle with x axis. So, if the angle with x axis or real axis it is theta, then I know tan theta is equal to height by beta by alpha, height by base. So, I can say theta is equal to tan inverse beta by alpha. So, any complex signal which in the form of alpha plus jb can be written in the form of amplitude and direction e to the power j theta, and theta is known, r is known. So, I replace alpha plus j to the power n. So, r to the power n e to the power j theta n un is a complex signal. Okay? So, this is called phase term and this is called amplitude term. But in case of a real signal, it is a cos omega t plus theta which has a real amplitude. Understand? So, the real signal and complex signal. Now, I come to the multi-channel signal and multi-dimensional signal. So, multi-channel signal, that means I have a separate sources, several sources, multiple source of signal. So, suppose I have recorded a voice. One is music and another is vocalic. Today, if you go to the speech recording studio, you can find as a multi-channel recorder. Today, it is not necessary that music has to be recorded during the vocalic, as synchronous. It is not asynchronous. First music recorded, maybe first violin recorded, then maybe tabla recorded, then maybe voice recorded, vocalic recorded. So, there is a multiple channel. So, multiple source of the signal are represented. If I have a signal which is a multiple source. So, I have a multiple channel signal. So, I can say multi-channel signal. So, this is a multi-channel signal. Another example, you said stereo signal. All of you know about, I have a stereo. Initially, before that 5.1 channel music system. How many of you have in your home 5.1 channel music system? What is 5.1 channel music system? First, think about the stereo system. If you see the revolution, that initially it is come stereo sound. You have heard about the stereo cassette, mono cassette. So, stereo means I have a left and right channel, left channel and right channel. So, stereo signal is nothing but a multi-channel signal which has a two channel. One is left channel, another is right channel. .1 channel audio system. So, if you if you are playing a recording sound which is not multi-channel, then if you play it in a 5.1 channel music system, it does not give you that effect. So, if I have a multi-channel recording system and then I play it in a multi-channel player, then I get the effect of that channel. So, what was those effects? Why the stereo is come? What is the problem in mono? Think on it. What is the problem in mono? What stereo solve? Then what do you mean by multi-channel? Dolby Digital, you have heard about Dolby Digital movie theater hall. What is Dolby Digital? It is nothing but an encoding system, coding system. So, what is Dolby Digital? 5.1 channel. So, it is a multi-channel signal. Okay. So, I will come later on what is Dolby Digital, those things. You can also think on it. What is Dolby Digital? So, multi-channel signal means I have a several channel. So, if I represented in a mathematics, I have a signal which is there is a multiple channel signal are combined together. S1 is a channel, S2 is a channel, S3 is a channel, S4 is a channel. So, it is a 4 channel signal, not 3 channel, 4 channel signal, S1, S2, S3, S4. So, during audio editing, why this multi-channel signal is required? If you say, suppose I have a vocalist and I have a background music. So, I want to reduce the background music when an important conversation is happening. If you see in a movie, when an important conversation happening, the music is stopped, and when it is reaches climax, there is some background music is prominent. So, how do I do that? I put the voicing in one channel, background music in one channel. I can fade the background music or reduce the amplitude of the background music during that time, and after that, when this is a climax point, here I can produce an extra music here. So, that when it is climax point, then and there a background sound will come. So, that is why the multi-channel signal systems was come. Okay. So, signal can be multi-channel and signal can be multi-dimension. If I say XAT is equal to A cos omega t plus theta. If you see along the timeline, the amplitude of the signal is changing. Along the timeline, amplitude of the signal is changing. So, I can say it has a one dimensional signal Okay or not? Only this direction signal is changing. So, this may be a t, this may be a x. So, this x-ray t, value of x-ray t depends only on t. T is an independent variable. Now, if I say, you know that when I say y equal to ax, you know the y is depends only on x. Now, if I say y is equal to ax1 plus ax2, where x1 and x2 are an independent variable, then I can say y has a two dimension. Or I can say f function is equal to ax plus by. So, I know the function f has a two dimension, x and y. Two are independent variable. So, if a multi-dimensional signal, if I have a m number of independent variable, so I have a signal whose dimension is m. Example, let us take this picture. How many information is there in the picture? If you see, let us see the color picture. So, I know the picture is changing along this direction and picture is changing along this direction also. So, picture, this is, let us say this is 0 0. So, in the value, color value is changing along this direction also, and color value also changing along this direction. So, I can say a picture has a dimension which is called x and y. So, either color, if it is black and white picture, it is only intensity. So, intensity is changing along the both spatial direction, one is x direction, one is y direction. So, that is why I can say it is a two dimensional picture, two dimensional signal. Image is a two dimensional signal. So, either color or black and white, the color will be function of x, y, z, or the intensity will be function of x, y, z. So, intensity, you know that color image, intensity of R, intensity of G and intensity of B, that is function of x, y, z. If it is black and white image, I is a function of x, y, z. If it is a binary image, I know the value of the pixel will change along the x axis and along the y axis both. So, every pixel has a coordinate in x and y. So, that is why I call it is a two dimensional signal. Now, when I watching a movie, so it is not a still picture, it is an x and y dimension, but it is also changing along the time. When you play the movie, it is nothing but you are changing the time. So, it is x and y along with time. So, I can say movie is a three dimensional signal. I have a three dimension, x dimension, y dimension and t dimension. So, I have a multi-channel signal and multi-dimensional signal. Multi-channel is not changing the dimension. The complexity of the signal will be same in case of multi-channel signal or maybe different, but the channel wise, it is a source are different. But when I say multi-dimension, signal has a multiple dimension. Signal depends on multiple independent variable. So, here independent variable is x and y, and here also x and not only x and y, x, y and t. When I say I am speaking, this acoustic signal when it travels in the air, if you see how many direction it can travel. So, let us see the pressure wave. So, the pressure wave can travel x direction, y direction, z direction both. So, the pressure wave is a function of x, y, z and also t. So, if the pressure wave is a signal, so it depends on four independent variables x, y, z and t. Understand? So, this is the multi-channels and multi-dimensional signal. If I ask you another important example, let us say I give you, then if I ask you what is Ohm's law, what is Ohm's law? People will say V equal to IR. Okay, then there is another condition when all the physical property remain unchanged. So, Ohm's law you have learned in class 8, class 9, class 10 plus 2 and physics honors or engineering. What is the difference? How the complexity of I and V changing with the induction of different dimension. I is a signal, current is a signal. So, how the signal, current signal, the dimension has been changed. Initially you say all the physical property remain unchanged. Now, if you just break that term and add the complexity on the I. So, I initially you said I is a function of t. Then you said I is not only function of t, it is also function of position and time. So, I is a function of x, y, z and t. V is a function of x, y, z and t. So, you are changing the complexity of the. So, if I increase the dimension, the complexity of the signal is changing. Okay? So, I will stop here today. So, next class I will talk about the characteristics of the signal. Okay? Thank you.